Hola, mi clase. So we're moving on to volume 13.1, volume of cylinders. Oh, not supposed to have a space there. I can know and use the formula for volume of cylinders. So we need to memorize this. The standard is that you have to know this formula by heart. So you definitely need to make some flashcards for these formulas that we're going to learn in 13. So volume of cylinder, V is always for volume. It's the radius, is the area of the base, cylinder with radius. So we always have to use the radius. If it gives us a diameter, I'll show you what to do with that. It's the area of the base, so that's the area of the circle on the bottom, times the height. So it's like taking quarters and then stacking them. Okay, that's kind of how you can think about it, right? 1 quarter, and then if I stack 10 of them, the height would be 10. So that's what we're doing. So sometimes you'll see it as volume equals this capital B, and this capital B means area of the base. But because the area of a circle will always be the same thing, we just tell you what it is, which I'll get to, area of base, and they mean base like bottom of the shape. So right here, oops, I don't want to cross it off, is pi r squared times height. This is the same thing, area of the base, because that's the area of a circle, right? So pi r squared is how we find the area of a circle. And that's why pi was showing up in your guys' Desmos yesterday, or I should say today. Today. All right. So height, radius. Here we go. So we are going to find the volume of this cylinder. We're going to round all our answers to the nearest tenth, and then if necessary, and we're going to use 3.14 for pi. Okay. So we are going to get to use a calculator. So here is the radius, and here is the height. So our volume is pi times radius squared times height. So we are going to change pi to become 3.14. Technically, if I change pi to become 3.14, we're going to put an about symbol here. And that's because 3.14 is not an exact answer of pi, but it's really, really close, so that's why we use it. R is 3, so I'm going to go 3, and I'm going to square it, and then I'm going to times it by the height, which was 10. We have to do exponents first, so I'm going to go 3.14 times 9 times 10. I can then even do 3.14 times 90, just do 9 times 10. Then I'll finally get my calculator out and do 3.14 times 90, and we would say this is approximately 282 6/10, and it's going to be inches cubed. All volume is cubed, but the reason why is right here where we have 3 squared, right? 3 times 3, that's inches times inches, so we get inches squared. And then right here, we times it by that 10. Well, if we take inches squared and times it by another inches, it's the same as inches squared, cubed. So it's just like if I took, 3 times 3 times 3, we would say 3 cubed. It's the same idea. So that's where the cubed comes in. All right, but there's our final answer, and I didn't need to round. It came out exactly as 6/10, so I didn't have to worry about rounding. All right, let's look at question B. Now this, see how the line is all the way across? This is not the radius. The radius only goes halfway, okay? This is actually the diameter. But our formula must have the radius. I cannot find the volume of a cylinder without the radius. The formula does not work. So what we have to do first is we actually have to take the diameter and divide it by 2 to get the radius. So I'm going to take 6 4/10 and divide it by 2. And 6 4/10 divided by 2 is 3 2/10. and that's my radius. Now that I have my radius, I can use my volume formula. So I'm going to go pi times radius squared times height. Again, I'm going to estimate pi to be 3.14. I'm going to multiply that by 3 2/10 squared. We always square it. It's just the formula. And then I'm going to times it by 13. And I know right now that doesn't look like the height, but it's like a roll of quarters in the little roll-up thing where I lay it down. So that's how we can think about this. So there's my circle, and then I laid them this way, like they're already like tied together. It's like taking a can and laying it on its side. We would still consider this the height, okay? So I can't really do any of these in my head, so I'm going to do 3 2/10, and I'm going to square it. And you'll notice I always put every step that I do. Okay, so when I square this, I get 24 hundredths, and then I'm going to times it by 13, 10 and 24 hundredths. I'm going to times it by 13. So now I have 3.14 times, it's 133 12 hundredths. And then I'm going to times it by 3.14, and we get approximately 417.9968. But the directions told us to round in the nearest tenth. So if I look at the tenth, it's a 9. I look at the number behind it, it's actually also a 9, so it rounded up. But if I round a 9 up, it's also, that becomes a 10, which means I need to round this up. So we would say our final answer, which I'm going to put over here, is approximately 418 centimeters cubed. Okay, this is my answer here. And that all happened because of the rounding. Notice I didn't round to the nearest tenth until the very, very end. I left it as 24 hundredths, I left it as 12 hundredths, and then once I finished all my math, I then round. We do not round until the very, very, very end. All right, it says Big Bertha has a diameter of 8 feet and 4.5 feet deep. Okay, so deep is the same thing as height. They just kind of look at it this way, right? Find the volume of the drum to the nearest tenth. So this is a drum called Big Bertha. Its diameter is 8 feet. So remember, diameter is all the way across. So this is 8 feet. And then we aren't looking at it correctly, but if it was laid down, the height would be 4.5, right? We're looking at it from the top. So the first thing we have to do is we have to take that diameter and divide it by 2 to get the radius. So I'm going to take 8 and divide it by 2 and get 4 to get my radius. Now that I have my radius, I can go volume is approximately, I'm going to just estimate it right now, 3 14 hundredths times 4 squared, and then times 4.5. Okay, and again, deep can also mean height. Okay, so 4 squared is 16. So 3.14 times 16 times 4.5. When you're doing these timesing, just try to make sure you put your decimal pretty low so you can tell the difference between the two. So if I take 16 and times it by 4.5, we get exactly 72. I'm just going to check it just in case. 16 times 4.5. Okay. Then I'll take that and times it by 3.14. And I get 226 and 8/10. Sorry, I lied, 8 hundredths. One more over. 0.8. It does say round to the nearest tenth, right? Find the volume to the nearest tenth. So we would say approximately 226 and 1/10, because the 0 will get bumped up from this 8, and we will get feet cubed. And there's our final answer. Notice I keep it approximate the whole time, not only because of me changing pi to 3.14, but also because I rounded. So that's the 2 reasons why we technically have to put an about symbol. It's not exact, but it's very, very, very close. All right, so this question's a little bit different. It says the volume of a drum is 144 pi inches cubed. So they just have it times by pi. That's what this means. is the volume is 144 times pi, okay? So they just have it times by pi, which is fine. The height of the drum is 4 inches, and they want us to know they want us to find the diameter, okay? So if volume is pi r squared h, what we're going to do is fill in everything we can. So I know the volume is 144 pi. I'm going to set that equal to pi times, I don't know what the radius is, so I'm going to go radius squared, and then I'm going to times it by 4 because I know what the height is. So what we have to do is solve this like an equation. Since I am timesing by pi, I can actually divide by pi, okay? I don't know why I put 2 lines there. I can divide by pi, right? The inverse of timesing by pi is dividing by pi, but every time I do it to one side, I have to do it to the other side. But if you notice, I have a pi in the numerator, I have a pi in the denominator. Anything divided by itself is just 1. So I basically just canceled that out. And so I'm going to go 144 equals r squared times 4. We're going to then do the same thing with the 4. I'm going to divide by 4 because the inverse of dividing or multiplying is dividing. I'm going to take 144 and divide it by 4. And I'm going to come over here, 36 equals r squared. Now, we need to find out what I squared to get 36. So basically, I'm trying to see what is 36 if I take r times r. Okay, you can guess and check. You can just try some numbers, go 5 times 5 or 3 times 3, right? You also have technically a square root, right? We've talked about square rooting at the very, very beginning of the year. The inverse of squaring is square rooting. So you actually can, in your calculator, put 36 and push the square root button, and it actually will tell you that it is 6. Okay, now the radius is 6. It wants the diameter. So remember how when before we divided d by 2 to get the radius, we can take the radius and times it by 2 to get the diameter. So if I take 6 and times it by 2, I'm going to get 12, which is the diameter. So the diameter is 12 inches because my units were all inches, and now it's just a measurement. It's not 3 measurements like before. So that's how you use the formula backwards, is if it gives you the volume, that's what you would need to do to find pieces, right? Height or radius. All right, so the main thing to remember is to memorize that formula. You have to know it, okay? So memorize the formula. And then also 3.14 is going to equal pi, and I can actually insert a pi symbol in here. Where is it? Really? Here we go. Pi. All right. So here is your independent practice. You have 2 of them to do. Please write down everything that you do. So similar to how I just modeled it, right? I filled it in. I did 1 piece, 2 pieces, right? I went through each step. I do not want to just see an answer here. I need to see some work here, but you are welcome to use a calculator. So please use my models, this one, and this one, to show your work for these, okay? That's what I'm going to be looking for. All right, until next time, adios.